Imagine a star. It's a brilliant blue, shining bright. Now imagine this star is billions of years old. Here's the catch: it looks like a newborn. This is the perplexing reality of blue straggler stars. They are cosmic rule breakers, defying the natural order of stellar evolution. These celestial anomalies reside in the universe's oldest neighborhoods, globular clusters. These clusters, teeming with ancient stars, are like retirement homes for stellar objects. Yet, amidst the fading giants and dying embers, blue stragglers blaze with youthful energy. How can these stars appear so young when they should have aged alongside their neighbors? The answer lies in a cosmic dance of collisions, mergers, and stellar vampirism. To unravel the enigma of blue stragglers, we first need to journey through the remarkable life story of a typical star. Stars, those glittering points of light that fill our night sky, are not eternal. They are born, they live, and eventually they die. But their journey from birth to afterlife is a tale of cosmic drama, shaped by the forces of gravity, nuclear fusion, and time itself. To truly appreciate the mystery of blue stragglers, we must first understand the life cycle that most stars follow. This cycle is a grand cosmic dance repeated countless times across the universe, and it all begins in the dark, cold regions of space. Stars are born in immense, colorful clouds of gas and dust known as nebulae. These nebulae are the stellar nurseries of the universe, where new stars are forged from the raw materials left behind by previous generations of stars. Within these nebulae, gravity works its magic, slowly pulling together clumps of gas and dust. As these clumps grow larger, their gravity becomes stronger, causing them to collapse inward. This collapse generates intense heat and pressure at the core. Eventually, the core becomes so hot and dense that nuclear fusion ignites. Hydrogen atoms fuse to form helium, releasing vast amounts of energy. This marks the birth of a new star, shining brightly in the darkness of space. The fate of every star is determined by its mass. Massive stars and smaller stars follow very different paths through life, and their destinies are written in their very beginnings. The most massive stars burn with incredible brightness and heat, but they pay a price for their brilliance. They consume their nuclear fuel at a furious rate, living fast and dying young, sometimes in just a few million years. Smaller stars, like our own sun, are much more frugal with their fuel. They burn steadily and can shine for billions of years, providing warmth and light to any planets that may orbit them. As stars age, they undergo dramatic changes. Their color shifts, often turning red as they expand into giants, and their size can swell to many times their original diameter. Eventually they exhaust the nuclear fuel at their core, marking the beginning of the end. For the most massive stars, this end is spectacular. A supernova explosion that can briefly outshine an entire galaxy, scattering elements into space and seeding the next generation of stars. Less massive stars, like our sun, end their lives more quietly. They shed their outer layers and leave behind a dense, faint core called a white dwarf, a silent reminder of the star that once was, slowly cooling over billions of years. Blue straggler stars stand out in stark contrast to this stellar life cycle. They are found in globular clusters, which are ancient collections of stars that formed billions of years ago. The stars in these clusters are all roughly the same age, like classmates in a cosmic school. As these stars age, they should evolve predictably, with the most massive stars dying out first. However, blue stragglers defy this expectation. They are more massive and luminous than their neighbors, suggesting they are much younger. It's as if a group of senior citizens suddenly had a few teenagers in their midst. These youthful stars are out of sync with their surroundings, challenging our understanding of stellar evolution. For decades, astronomers were mystified by the existence of blue stragglers, stars that seem to defy the natural order of stellar evolution. In the vast tapestry of the cosmos, where stars are born, age, and eventually fade away, these peculiar blue stars stood out as youthful anomalies among their ancient neighbors. Their presence in old star clusters raised a profound question. How could these stars appear so much younger and more vibrant than the rest? The mystery deepened as astronomers observed that blue stragglers shone with a brightness and color that suggested they were burning hotter and faster than their peers. It was as if they had somehow managed to turn back the cosmic clock, maintaining a youthful glow in a universe where time marches relentlessly forward. The answer to this cosmic riddle, as it turns out, lies within the unique environment of globular clusters. ancient, spherical collections of stars that orbit the outskirts of galaxies. These clusters are not just beautiful to behold, they are laboratories of stellar interaction, where the rules of star life and death are rewritten. Within these clusters, stars are packed together with incredible density, sometimes separated by only a fraction of the distance that lies between stars in our own neighborhood. This close proximity creates a dynamic and sometimes chaotic environment, where the fates of stars are intertwined. In such a crowded setting, stars are far from isolated. Their gravitational fields tug and pull at one another, leading to a complex web of interactions. Some stars may pass by each other harmlessly, while others are drawn into close encounters that can dramatically alter their destinies. These interactions can be both spectacular and violent. When two stars collide, the result is a cataclysmic event, an explosion of energy and light that can reshape both stars, or even merge them into a single more massive entity. Sometimes these collisions are direct and head-on, fusing two stars into one. The new star, now more massive and energetic, burns hotter and bluer than its predecessors, taking on a new lease on life as a blue straggler. In other cases, stars form close binary systems, locked in a gravitational embrace. Over time, one star may siphon off material from its companion, drawing in fresh hydrogen fuel and reigniting its core. This process, known as mass transfer, can rejuvenate a star, making it appear younger and more luminous than it otherwise would. Through these extraordinary processes, stellar collisions and mass transfer, blue stragglers are born. They are living testaments to the dynamic, ever-changing nature of the universe, where even in the heart of ancient star clusters, the dance of life and death continues, creating new wonders for us to discover. Imagine, if you will, two stars bound together by gravity, locked in a cosmic dance that has lasted for millions, perhaps even billions of years. These stars, known as a binary system, orbit each other in a delicate balance, their fates intertwined by the invisible force that holds the universe together. Over time, their orbits can decay, drawing them ever closer. Eventually, the two stars spiral inward, their outer layers brushing against each other, until finally, they collide in a spectacular, cataclysmic explosion. This is not just a simple crash, it's a violent merging of two massive bodies, releasing an enormous amount of energy and scattering stellar debris across the cosmos. From the chaos of this collision, something remarkable emerges. The remnants of the two stars coalesce, forming a single, more massive star. This new star is born from the ashes of its predecessors, inheriting their combined mass and energy. It shines with a renewed brilliance, a testament to the dramatic events that created it. This newly formed star, now much heavier and hotter than before, burns with an intense blue light. Fueled by the fresh supply of hydrogen from its parents, it radiates energy at a much higher rate, standing out among its older, redder neighbors. In a cluster of ancient stars, this blue, luminous newcomer is a true anomaly. It appears younger, brighter, and bluer than the stars around it, a striking outlier in a sea of aging suns. Astronomers call this rare phenomenon a blue straggler, because it seems to lag behind in the aging process, defying expectations. But a blue straggler doesn't always have to be born from a violent collision. There is another, more subtle way these stars can form, through a process known as mass transfer. In this scenario, two stars in a binary system can interact in a very different yet equally fascinating manner. Picture two stars orbiting each other, one slightly more massive than its companion. As the more massive star ages, it expands, eventually growing so large that its outer layers begin to spill over onto its partner. The larger star, swollen and unstable, starts to lose its material to its smaller but still hungry companion. This transfer of mass is a slow, steady process, but it has dramatic consequences for both stars. The recipient star, acting like a cosmic vampire, greedily siphons off the fresh hydrogen from its neighbor. This influx of new fuel allows it to burn hotter and brighter, effectively turning back the clock on its stellar evolution. As the material streams from one star to the other, the recipient star is rejuvenated, its core reignited with the energy of youth. It becomes more massive, and its surface temperature rises, causing it to glow with a brilliant blue hue. This process of rejuvenation can dramatically alter the fate of the star, making it appear much younger than it truly is. Surrounded by the remnants of its companion, it stands out as a vibrant, energetic blue straggler. The stolen material doesn't just add mass, it reignites the nuclear fusion deep within the star's core, giving it a new lease on life. This transformation is so profound that, to an observer, the star seems to have been reborn. Whether born from a dramatic collision or a slow, steady theft of mass, blue stragglers are cosmic oddities, stars that refuse to age like their peers, shining as brilliant blue beacons in the ancient darkness of star clusters. While blue stragglers may appear beautiful and intriguing, they are also incredibly dangerous. Their intense gravity, radiation, and energy output make them perilous neighbors in the crowded confines of a globular cluster. Imagine for a moment what would happen if you got too close to a blue straggler. As you approach this stellar giant, you would be met with a blinding light, far more intense than our sun. The heat would be unbearable, melting anything in its path. The intense gravity would stretch and distort your body, pulling you towards the star's core. You would be vaporized in an instant, a testament to the immense power of these stellar anomalies. Despite decades of research, blue stragglers still hold many secrets. We don't fully understand the details of their formation or the long-term consequences of their existence. For example, we're not sure how long blue stragglers can maintain their youthful appearance. Do they eventually succumb to the same fate as their neighbors, or do they find a way to cheat death indefinitely? We're also unsure how common blue stragglers are in the universe. Are they a rare phenomenon confined to the unique conditions of globular clusters? Or are they more widespread, lurking in other corners of the cosmos? These are just some of the questions that astronomers are grappling with as they continue to study these enigmatic objects. Blue stragglers, while puzzling, offer valuable insights into the lives and deaths of stars. By studying these stellar outliers, we gain a better understanding of stellar evolution, the dynamics of globular clusters, and the extreme environments where stars interact and collide. These cosmic rebels challenge our assumptions and force us to refine our theories. They remind us that the universe is full of surprises, and that there is still much we don't know about the cosmos. By studying these stellar anomalies, we push the boundaries of our knowledge and gain a deeper appreciation for the vast and mysterious universe we inhabit. As we continue to explore the cosmos, we are sure to encounter even more strange and wonderful objects. Blue stragglers are just one example of the universe's capacity to surprise and amaze us. Their existence reminds us that there is always more to learn, and that the journey of scientific discovery is never ending. What other cosmic mysteries await us in the vast expanse of space? What new wonders will we uncover as we peer deeper into the cosmos? The answers to these questions are out there, waiting to be found. And who knows, maybe you, the reader, will be the one to make the next great discovery.